in London.
Hello, Governor.
Far milder than winters in Calgary, Alberta.
It's cold, eh?
When both cities are the same distance north of the equator. And what makes January in Perm, Russia
Здравствуйте. Hello.
so much more frigid than midwinter in Juneau, Alaska,
Nice day.
when Juneau is 4,000 miles due east? Why do some places at high latitudes have such moderate climate, while others are left in the cold? Baking under the tropical sun, the hottest parts of our planet could be much hotter, but some of that heat is spread towards the poles. Anyone outside the tropics who has experienced a blistering summer heat wave has felt the atmosphere's ability to move heat and moisture across the planet. But the atmosphere is only part of the story. There's also the ocean. In 1769, an assistant postmaster general named Benjamin Franklin came across an oceanic curiosity.
I found myself perplexed.
Why was it that ships carrying mail from America to England
Dear Father, would you be so kind as to send me my party hat?
arrived much sooner than the ships carrying mail from England to America?
Dearest Gail, it pains me greatly to say it, but my beloved horse, Mr. Edward, has eaten your hat.
This was too great a mystery to ignore. On my next few trips across the Atlantic, I started to chart the borders of what I discovered were large currents of warm water. By using barrels to capture seawater, I discovered that water just below the surface was much colder than water on the surface. This was true even in the hot tropics. You see, warm water is less dense than cold water. Heated by the tropical sun, it floats over the layers of cool water below. From this discovery, I created a map of what I called the Gulf Stream current. I realized the Gulf Stream was like a river running across the surface of the ocean. It wasn't just carrying mail ships. It was also bringing warm water from the tropics to the North Atlantic. Another scientific mystery solved.
Years later, other scientists and sailors would begin to better understand exactly how these currents worked. Wind patterns and the rotation of the Earth drive the warm surface water into Franklin's river-like currents. As these warm currents flow from the tropics to the colder regions far from the equator, they release heat and moisture to the air. All that warm, wet air moderates climate nearby, so a city like London is saved from the cold and snow. Instead, it's mild and damp.
Daddy, it's raining again.
After losing enough heat, surface water becomes cool and sinks, with more cooling water flowing down all the time. The cold water at the bottom of the ocean forms huge underwater rivers. These deep currents can travel for thousands of miles and hundreds of years before running into the continents, returning the water to the surface to be heated again by the sun. It's the light and heat from the sun, energy, that powers global climate. The oceans act like a giant battery for that energy. They store it in warm water and move it across the planet through currents. The ocean stores so much energy, in fact, that just the top 3 meters of the seawater can hold as much heat as the entire global atmosphere. The exchange of heat and moisture between the oceans and atmosphere maintains global climate, as we've observed it for thousands of years. But human activity is now warming the atmosphere. We are changing this system, and we need new tools to understand what will happen to our climate in the future. So, So, scientists make a new Earth to test our ideas, or at least a computer simulation of the Earth. Computer climate simulations, or models, are made by first splitting up the planet's land, oceans, and atmosphere into tiny three-dimensional boxes. And then scientists program the physical behavior of our climate systems, along with past scientific measurements and observations, into each box in the form of mathematical equations. The result is an advanced computer simulation functioning just like the world outside our windows. We can use these models to study ocean currents around the globe on the screen of a computer or on the surface of a sphere. But when we add the rising temperature of our planet into our models, the familiar climate moderating actions of the oceans and atmosphere start to change. And in the complex system of global climate, each new change can have uncertain and far-reaching effects, making our vision of Earth and its future a little foggy. So scientists around the world continue to study the interactions between the atmosphere and the oceans. At research stations and monitoring facilities on every continent and ocean, we're gathering data to build more sophisticated models so we can create a better scientific understanding of the changes our planet is undergoing. We know how the current temperature affects all of us, but how temperature currents could change our world is the kind of scientific mystery we can't ignore.
Oh, where's my umbrella? Куда подевалась моя лопата? The snow shovel!
It's not that cold up here. Shh. That's our little secret. 20 below zero. Could be worse.